This is the second example of writing equations of lines parallel and perpendicular to a given line through a point. So we have an equation in standard form. So guess what? We're going to have to work on it a little bit. Let's go ahead and move the negative 3x to the other side first. So we'll have negative 6y equals, now that negative 3x is now a positive 3x on the right side. And you bring down that positive 1 as plus 1. Okay, so that was a good start. Let's divide everything by the number in front of y, the number that is getting multiplied by y. So you have to divide everything by negative 6. Divide by negative 6, divide by negative 6, and divide by negative 6. Negative 6's cancel out here. I'll have y equals, but look at this part. This is important because that is the slope of this line. I can see that the number is negative because we have a positive over negative. So I'm going to pull out that negative in front of this fraction. And 3 over 6 reduced is, because 3 is half of 6, this is simply just negative half x. And if you want to simplify this y-intercept, positive divided by negative is a negative number, so we can say minus 1 over 6 there. I will circle this fraction. Why? Because this is the slope. This is the slope of the original line, and that is important. This is what we are going to use to find the equation of a line that is, first, let's do the perpendicular. So if the original line has a slope of negative 1 over 2, the perpendicular slope, I'll just go ahead and say m here. The perpendicular line should have a slope of opposite reciprocal. So I'm going to make this a positive, and I'm going to flip the fraction 1 over 2. Negative reciprocal of negative 1 over 2 is just going to be positive 2. Okay, so moving on to the point, they said the x of 1 is negative 4, and y of 1 is negative 4. I have all three numbers that I can plug into my point slope form. So here comes point slope form. I'll do y minus y1 equals m times x minus x1. Plugging in negative 4 and negative 4 for the y1 and x1 value, I will get y plus 4, because subtracting a negative is adding, right? Equals 2 times x plus, I don't like the way my x looks, x plus 4. Now I got the equation, but I have a strong feeling Alex will ask you to write this in slope-intercept form. So I'll go ahead and distribute this. That will be y plus 4 equals 2x plus 8. Lastly, subtract 4 from both sides to cancel that 4 out. Our final answer is y equals 2x plus 4. Now you're ready to check this answer with me on Desmos graphing calculator. Well, I think I just found the answer. What I'm saying is this equation that I just found must be the equation of a graph that is perpendicular to the original line. And that point is not only perpendicular, that line is not only perpendicular, but it's going to go through the point negative 4, negative 4. So I'm going to check that graphically, okay? So take a look at what I'm doing. I'll go to Desmos graphing calculator. Keep coming up in Korean. I don't know how to fix that. The original line is negative 3x minus 6y equals 1. So what I did was I graphed the original line, okay, the one they gave us in the beginning. And then what I'm going to do is, my answer is y equals 2x plus 4. So I type both in. And what I see is a red line and a blue line. Oh, and they look perpendicular. I can get a piece of paper, put the corner in here, and I will see that it fits perfectly at a 90-degree angle. Not only that, if I go ahead and plot a point at negative 4, negative 4, negative 4, comma, negative 4, and I'm gonna label it. Where are you? Where's the -4, -4? Plot it. Oh, you see? It is going through this, my answer, my line. So definitely we got the right answer. So this is what I suggest you do when you are done getting your answer algebraically. You know, quickly get a graphing calculator and you should be able to check it graphically, okay? All right, this was good. All right, let me do one more here. This time they say find the equation of a line that is parallel. Well, to be parallel, it needs to also have a slope of -1/2, the same slope. So I'll tell them that the slope this time has to be -1/2. I think the points are the same. X of 1 is -4 and y of 1 is -4. And when we are done writing it, we'll go back and check on it again on the graphing calculator, okay? So here's a point slope form. Y minus y1 equals m times x minus x1. If we plug in everything, we'll get y plus 4 equals -1/2 of x plus 4. Distributing this -1/2, I'll get y plus 4 equals -1/2 x, and -1/2 of 4 is negative, to half of 4 is 2, and the sign has to be negative, so that's what we got. Lastly, subtract 4 from both sides. Here's my equation. Y equals -1/2 of x minus 6. So what I'm now going to do is I'm going to go and graph this. I'm going to go ahead and graph this, okay? I'm going to see if this graph, if this line passes through this point -4, 4, and if it is parallel to my original line, okay? So over here, I don't think I'm going to delete the previous one. They all look good. I'll do y equals -1/2 x minus 6. So this is the answer that I just got. Oh, how perfect this is. Do you see this purple line that is parallel to the red original line? And it goes through that point -4, 4. Well, you know, I would do this because if you are on your third one on your ALEKS homework, you don't really want to miss that, right? So I suggest that you check your algebraic work graphically to see if the lines come up to be parallel or perpendicular and also are passing through that given point. So that's enough for this lesson right here. Do write me emails if you guys see any different types of problems on your ALEKS this week, okay?